Yes. Okay, good. So we're starting with properties of probability. And again, we say probability is non-negative. In other words, it cannot be negative. And when you have when probability is given as 0, it simply means the event cannot take place. Okay? While if the probability is given as 1, then the event will surely take place. So usually probability is measured between 0 and 1. That's why you see that inequality sign on the screen. Between 0 and 1. So this is 0, this is 1. So again, we have it stated. Now again, I told you probability can also be expressed in percentage. But like I told one of your, like I mentioned during the last class, if I don't tell you to express in percentage, it is presumed you're going to express it as a fraction or between 0 and 1. Now, other terminologies we'll also look at with respect to probability is the phrase statistical experiment. Statistical experiment means repeated trial. Trials is an act of an experiment, an attempt of experiment. Okay, 1 trial, 2 trial, 3 trials. Okay, outcome, this is the result of a trial, male or female. The event is described as the occurrence of interest, that is events. Sample space, that is the total set of the possible outcome of your experiment. While we talk of equally likely, the outcome that have equal chance of occurrence. Okay, so again, we can have what we call probability thermometer. You can have highly probable, you can have low. Okay, so you can view probability from this thermometric perspective too. Okay, and again, we talk of type of event. I've told you what an event is. That's the occurrence of interest. That is an event. So you can have a simple event, you can have a compound event, you can have the complement of an event. A simple event is an event with only one possible outcome, while a compound event, you can have more than one possible outcome. Now, the complement of an event is the event that can only happen after if the other event failed to happen. Okay? If a man did not survive, it means the man died. So, death and survival becomes complement of each other. Okay? So, death is the complement of survival. Survival is the complement of death. Am I still with my class? Are you still there? Can you hear me?
Yes, sir.
Oh, yes.
I can hear you. Oh, yes.
Great.
We can.
So again, complement of an event, okay, this is just what I just explained now. An event which occurs when and only when the other event does not occur. That's the complement of an event. So you see the manifesto of an aircraft that crashed near Lagos some time ago, carrying 100 passengers, consists of 75, 78 survivors and 22 deaths. Now, what is this? What is the probability that a name drawn from the list will be a survivor? The survivor here is the complement of death, just like success is the complement of failure. For VPH 527, if you don't pass the exam, you are likely to have failed the exam. So, passing becomes the complement of failing, okay? And vice versa. Okay. So the solution to complement, you can have probability of A plus probability of its complement will always be equal to 1. The probability of an event happening plus the probability of its complement will be equal to 1. And the probability of an event is equal to 1 minus the probability of its complement. These are just these are things you should be familiar with. The probability of if the probability of female is 15/40, then the probability of its complement male is what? It's going to be 1 minus probability of female, which will give you 25/40. Now, also we'll talk of the probability of
in the previous slide, I didn't really get the formula you are explaining. Like that, the P that has a something on top. I don't know what.
I said this. What can you see this? Can you see this slide? Can you see this slide? You can see where my cursor is hovering. My cursor is hovering under this PR means probability of A. A is an event, okay? While A bar is the complement of A, okay? So I said the probability of A plus the probability of its complement is equal to 1. Is that one clear?
Yes, sir. Yes, sir.
Good. So, and the probability of A is equal to 1 minus the probability of its complement. That one is clear too. Good. And I've just given an example here that the probability of female, if the probability of female is 15 over 40, then the probability of its complement, which is male, what's the complement of female? It is male. Okay? So then the probability of its complements is PM, probability of M is equal to 1 minus the probability of female, which will give you 25 over 40. So what you're simply doing is that you put the probability of female here, you subtract that from 1, you get 25 over 40. I can say what is the probability. I can look at it from the number that make up this particular class. If just looking at my participants check, I have 16 of you, okay? 16 of you over the total class roll. That should be 16 over 76. I think your class enrollment is 76, if I'm right. So 16 over 17. The complements to that your class will be 76 minus 6. 90 what?
92.
You are 92 in that class.
Oh yes, yes, sir.
Allow the lecturer now. Allow him.
We are about 92, sir.
92. Good. That's all right. That's all right. That's all right. So if you subtract the 15 I'm seeing here from 92, then you should have the number left. So the number left over 92 will be the complement of 16 over 92. I hope that is clear. Just for illustration's sake. Just for illustrations. Okay, good. So again, we talk of the probability of 2 or more events. Composite events A and B, the events A and B occur if both event A and event B occur at the same time. So we describe that as composite events. Okay? It means 2 events that must occur together. So when you say 2 events are composite, it means you can't have A without having B. Okay? And also, we also talk of mutually exclusive events. Mutually exclusive events. These are events that if one occurs, the other cannot occur. Okay? That is mutually exclusive events. Good. There are some things I'll be saying.
Sir,
please.
I don't get.
You didn't get. What didn't you get?
The one for this mutually one, you say that if one occur, the other cannot occur.
Yes, now that mutual, when you say 2 events are mutually exclusive, that's English word now. That's grammar, that's English grammar. When you say 2 events are mutually exclusive, it means if one did not, if one has happened, has occurred, then the other cannot occur. The occurrence of one eliminates the second one. Okay? The occurrence of one.
Yeah, but that means, but it is seeming like it is almost the same with that of complement.
No,
event.
Composites. Complement.
Okay, so.
No.
Because that.
Don't mix it up. Let's go back to complement of an event. The complement of an event. The complement of an event. Just a minute, please. Something is disturbing my screen here. Let me copy. Okay, let me just continue. Can you still see my screen? Can you still see my screen?
Yes,
Yes,
sir.
sir, we can.
Okay, great. I'm getting some notification that are disturbing me here. Okay, good. So when you say complement of an event, let's go back to it. Complement of an event which occur when and when only the other one does not occur. Okay, but please understand, complement is looking at it from a single, a whole perspective. For example, you say, let's assume we have a class, okay? A class that comprises 4 female and 6 male, okay? 4 female
Yes,
and
sir.
6 male, okay? So 4/10 is the complement of 6/10, okay? We're looking at it from
Yes,
a
sir.
single piece, okay? When you remove this, whatever is left, that's how we view the word complement, okay? But when you talk of
Yes, sir.
mutually exclusive events, you are looking at two independent events that when one happens, the other can no longer happen. Are you getting it? It may sound a little bit
Yes, sir.
similar, but it does not necessarily make them the same.
Okay, sir. Can you give us like a practical example of this mutually exclusive event so that we can relate it?
Okay. Mutually exclusive events. Can somebody give us an example? You can talk of presence and absence. Present and absent. Present and absent. Are you getting it? If somebody is
Yes, sir.
present, he can't be absent at the same time. Let's just go ahead. We'll get to understand it as we continue. So
Okay.
now, if you look at my screen, you have a contingency table. You have a contingency table here. You could call this 2x2 contingency table, where you have abnormality, distribution of 800 newborn by sex, and congenital abnormalities. Okay, you have the abnormal, you have the normal, you have male, female, congenital abnormalities. Okay, this is a distribution of 800 newborn by sex, maybe in a particular hospital. Okay, so you can be asked questions relating to probability with respect to this 2x2 contingency table. Now look at this question. Question 1, probability of a newborn being an abnormal male. If you pick a newborn from the hospital, what is the probability that that newborn is an abnormal male? Can somebody help us? Look at the table again. Can somebody screenshot that table? Please, let everybody screenshot the table, or you copy it somewhere, screenshot it, and let's attempt the questions together. Are we done? So let's look at the questions together. Probability of newborn being an abnormal male. What should be the answer to that? Probability of newborn being abnormal male. Abnormal male. Can somebody help us with that?
I'm thinking that it should be 70 over 800.
Perfect, good. 70 over 800. Good. The second question is there.
Thank you,
Probability
sir.
of the newborn being a normal boy. Any other person? Where is Kachuku? Kachuku. Where is Kachuku?
Akachuku, where are you?
Akachuku, is Akachuku on this thread?
No, sir. It seems like he's busy with something urgent.
What could that be? I'm not sure I've seen Akachuku on this thread since I started this
Or
class.
maybe
Eh? Did his wife put to bed? Did the wife put to bed?
No, sir.
Oh,
Maybe
I've
there is
not,
power failure in his side.
for the past 4 classes, the 4 classes I've had, I've not seen Akachuku. Please tell him that if there's any problem he has with the EEDC, he should please say to it. And he should call me, please. So the second question is probability of newborn. The probability of newborn. The probability of a newborn being normal born. Who can help us with that? What's the probability of a newborn being a normal? Who is speaking? Precious. You said what? Precious.
Sir, please, can you show us the table again?
I told you to screenshot the table.
We did, but if I will go to the table now, I will use this platform
Oh,
to now
yeah.
enter. Okay. Then it is like she said.
What did she say? What did she
330
say?
over 800.
Okay,
330
great.
over 800.
Okay, great. So I want to assume you all got the gist. So let's continue. So
I'm not understanding how they are getting the values. So I don't understand anyone.
who does not understand? Who is speaking? Who doesn't understand?
I don't understand how they are getting the calculations, like how they are getting the 70 over 100 and 30.
Esther.
33, I mean,
That's Esther, right?
yes, sir.
You want?
Okay. So when you look at if you have studied the table very well, if you have studied the table very well, okay, when you talk of abnormal male, you have it, you found it in this box. In this box, this is the number for the abnormal male. This is the number for abnormal female. This is the number for the normal male. And this is the number for
Normal female.
the normal female. Good. The normal female. So that's how we get it. Okay? You just look at the number and you put it over the total. That's how to calculate probability. I hope that is clear, Esther.
How come she said 70 over 100? Because calculating 50.
Who said 70 over 100? It should be 800. For
I said
abnormal,
800.
330 over
No, the
800.
one you said 800 is for 330 over.
The answer to the first question, we said 70 over 800. And then to the second one, we said 330 over 800. We never mentioned 100.
Okay, so that means it's going to be the male over the total number of all the babies, not just the abnormal babies.
Yes, like he said.
Yes. Yes. All right, so let's continue. So we continue. For single events, we have the formula here. For single events, we have the number of possible events over the number of possible equally likely outcome. Okay? And you have it on your screen. Independent event, you have it there. These are basic arithmetic. We're not going to spend too much of our time on all this. They are basic things you did in your O level. So if you needed any further clarification, please, I'll give you the notes. You brush it up, or you go and pick up general mathematics and look at it again. Okay. So mutually exclusive, non-exclusive events, and all the like. So we come to the area of our main concern. We're looking at probability distribution. Okay? Probability distribution. Now, we talk of random variable under probability. Random variables. Now, the distribution of random variable is what we describe as probability distribution. When you have events, when you arrange events according to their corresponding probabilities in a tabular form, we describe it as probability distribution. So, looking at the screen, sorry for that interruption. Looking at the screen, you have an example. In a ward, there are 5 patients. If 2 are short-sighted and 3 are long-sighted, if 2 patients are selected at random without replacement, form a probability distribution table for the random variable x, where x is the number of short-sighted patients selected. So, when you have the outcome of an event, when you have the outcome of an event, you arrange in a table according to their probabilities, their corresponding probabilities. We describe this as probability distribution. For instance, if I say a fair dice, I'm sure you know what a fair dice is, okay? If you toss a fair dice, you can write down the probability of having 1, 2, 3, 4, 5, or 6. You can write them down. You can put them in a table. Okay? So when you do that, that is probability distribution. Now, probability distribution can be presented in 3 ways. Number 1, you can present it in table, just like we have it in our definition. You can also put it in form of a diagram, and you can also express it mathematically, just like mathematical equation of probability distribution. Good. So, there are 2 types of probability distribution. Let me bring up a whiteboard for the purpose of illustration. I want to show a few things. So I'm going to stop sharing this now so that I can bring up a whiteboard. I hope you are still with me. Good. The whiteboard is loading. Just a minute. Okay, we're here. We're here. So when you have probability distribution, probability. Can you see my whiteboard? I believe you can see it. I believe you
We can see your whiteboard, sir.
Okay, good. So there are 2 types of probability distribution. We have discrete. Excuse me. We have discrete probability distribution. We have continuous. Excuse me. So, discrete probability distribution and continuous probability distribution. Okay? So, we're going to be looking at this. We'll start with this, okay? And after we'll end everything with continuous probability distribution. I hope that's clear. Okay?
Yes, sir.
Then I go back to sharing my screen. Okay. Please give me a minute. Just give me a minute. I'll be back. Just a minute, please.
Excel, please stop making noise.
Yeah, I'm back now. Sorry for that break in transmission. Okay, so like I said, we're going to look at the discrete probability distribution today. Okay, after which we'll move over to the next type of probability distribution. Now, discrete probability distribution, I once explained what the word discrete means to you. Okay, discrete means absolute. It means integer. These are values that are not that cannot take, like they can't take a value between two whole numbers. Okay, when you say a value is discrete, it means it's absolute, like 1, 2, 3, 4, 5. Okay, but when you say continuous, it means you can have it as decimal fraction and the like. Okay, so we have what we call the discrete probability distribution. And there are four types of discrete probability distribution. We have the geometric distribution, the binomial distribution, Poisson, and hypergeometric distribution. We are going to focus ourselves. We're going to focus on just two types of this probability distribution. If you check your screen, we're going to focus on just these two. Number one is the binomial distribution, and number two is the Poisson distribution. Am I still with you?
Are still with us.
Okay, great. So we look at binomial distribution, we look at Poisson distribution. The geometric and hypergeometric they are beyond the scope of this class. Okay. So we continue. Let's look at the binomial distribution. Binomial distribution is a kind of binary distribution repeated n times. Okay. What is binary distribution? Binary distribution, you talk of a kind of event outcome that has two possible outcomes. Okay. Two possible outcomes. When you say yes or no, male or female, true or false, these are two possible outcomes. So we describe the distribution of such binary event, okay, as binomial distribution. I hope that is clear. Okay. So we describe it as binomial distribution. And now, for every distribution you are going to meet in statistics, there are properties of that distribution. So we're going to be looking at the properties of binomial distribution. We also look at the properties of Poisson distribution, right? So for binomial distribution, the first property we look at is the fact that there are possible outcome of a trial. Number two, the trial has two possible outcomes. And when you say two possible outcomes, another word to describe that is dichotomous. We say it's a dichotomous variable, a dichotomous outcome. In other words, two possible outcomes. So the trial would now be repeated n times, okay? To be repeated as many times. That's n, using n to denote it. So we also talk of successive trials are independent, okay? Successive trials are independent. For instance, if, let's assume I gave you maybe an exam, 10 questions. And for each of the questions, you pick true or false, yes or no, okay? For the first question, you have yes or no. Second question, yes or no, okay? Somebody can pick yes in the first instance, and you can pick no in the next question. So that's what we mean by independent. So each of the questions is independent of the other, okay? So same probability of success and failure in each trial. Now, you will recall that I talked about complement of an event, and this is where you must bring that up now. Okay, the probability of success is usually given as P. This is our desired outcome. For instance, if your desired outcome is yes, You know there are two possible outcomes, either yes or no, true or false. Let's assume our desired outcome is yes. So our yes will be P, while our no will be 1 minus P. Okay? All right. So these are just the properties of binomial distribution. Let's have the mathematical expression of binomial distribution. You know, I told you you can express a probability distribution in form of table, you can express it in form of a diagram, you can also express it as mathematical equation. Now, this is the formula for binomial distribution. We refer to it as binomial formula, where you have the probability of R, which is success, is equals to n factorial over n minus R factorial, or bracket close, R factorial, p to the power of R, p to the power of n minus R. So, and I'm sure some of you have done further mathematics to some extent, so this should not be difficult for you. Okay, so this is a combination.
No, but not many of us. So
Don't worry, you catch up. You catch up.
okay, sir.
You know what factorial means. When you say 2 factorial, what does 2 factorial means? 2 factorial means 2 times 1. So what is 3 factorial? 3 factorial means 3 times 2 times 1. What is 5 factorial? 5 factorial means 5 times 4 times 2 times 1. Somebody is disturbing me here. Nokia. Who is Nokia? So that's what factorial means. Okay. So this is just the formula. Please don't forget this formula. You will always need it to solve questions relating to binomial. N factorial over n minus R, bracket open and close, all factorial. R factorial, p to the power of R, q to the power of n minus R. Now, if you look at this particular formula, the n here refers to the total possible outcome for an event. While R is the success. That is the probability of success. Okay. Now the P here is the success, while the Q here is failure. Don't worry, we are going to solve question of this, and it looks quite upfront now, but by the time we start solving question, you'll find it easy. Okay. So don't give up yet.
Sir.
Yes. Who
Sir,
is it?
please.
Yes, I'm pleased. Go ahead.
Sir, please, the last slide.
The last one. This one. Good.
That's the one. Like the n factorial, get a space, then something n, like bracket n minus R, all factorial, R factorial. Is this P, is it raised to power, as in, is it like, is the P raised to power like the R?
Yes, that P is raised to power of R. Let me write it here. Let me write it. Just look at your screen. This is what I've written here. N factorial over bracket open N minus R bracket close factorial R factorial. Okay. Now this P is a big P. Okay. It's a big P. Now raising to power of R. And now also this our Q is a big Q. The power of N minus R. Good. Is it clear now? Is it
Yes,
clear?
sir, it's clear.
Okay, great. Good. So now, still on binomial distribution, you can calculate the mean of a binomial distribution. The mean of a binomial distribution is the product of the total possible outcome multiplied by the probability of success. You have it here. Okay. Why? You can also calculate the variance of a binomial distribution, which is our n multiplied by p multiplied by q. The coefficient of skewness can as well be calculated, which is your q minus p over the roots of the product of n, p, and q. Okay. We call that our q is equal to 1 minus p. The same thing, our p is equal to 1 minus q. Good. So now let's have an example. Let's have an example on binomial distribution. An albino rats used to study the hormonal regulation of metabolic pathway are injected with a drug that inhibits body synthesis of proteins. Generally, 4 out of 20 rats die from the drug before the experiment is over. If 10 animals are treated with the drug, what is the probability that at least 8 will be alive at the end of the experiment? Now, please, I want you to put on your thinking cap and I want you to pay attention very well because this is where it gets tricky. Okay? The first question you should ask is that how did we know that this is a binomial distribution? Now, if you look at the question again, the question tells us that at the end of this experiment, okay, 4 out of 20 rats die. It means we are talking about death and what? And survival. And recall that one of the properties of binomial distribution is 2 possible outcomes. Hello, somebody? Can you all hear me?
We can hear you, sir.
Okay, great. So, if we look at this question again, the albino rats used to study the hormonal regulation of a metabolic pathway. Now, you have them injected with a drug that inhibits body synthesis of protein. Now, generally, 4 out of 20 die. Now, please take note, whenever you read a question on binomial, the outcome of interest is usually the first mention. It enjoys the first mention. For instance, if I want to talk about the performance of students over the years in statistics, I say usually what we have observed with VPH 527 is that out of 40, 15 usually pass very well. It means passing is our outcome of interest. In other words, that is a success. The outcome of interest is described as success, and it is denoted with the letter P. Letter P. Please, if you have your pen there, please write down. There are so many things I'm going to talk about. You will not see it on the slide. Okay? And jotting is also part of learning. You take note. So again, I'll repeat myself. I said, let's assume I want to give a kind of report about the performance of students over the years in statistics. That's the page 527. And then I said, usually that we have observed over the years that if 4 students sat for the exam, that usually 15 will pass. It means passing is the event of interest. But let me say it in another way again. If I decide to put it this way, that we have also observed that each time that this exam is conducted, 5 students usually fail out of 40. It means failure is my event of interest. And that pass for what? For success. I hope I've not confused somebody. Look at the question on the screen. 4 out of 20 die, which means death in this case is our event of interest. Somebody is banging something on my ear here. Nokia, please, who is this Nokia? Don't let me remove you. So, yes, Precious.
Yeah, so you just said out of 40, 15 pass and 5 usually fail. So what happens to the rest?
No. You are merging the two statements I made together. I made them independently. You understand? I say, let's assume, let me start again. Let me just say 15 usually pass out of 40. Okay? That statement indicates that 15 over 40 is my success. because that is the event I mentioned in the course of description or reporting. Okay, but let's assume you put that aside. Let's assume I decide to make it in a different way, and I say 5 usually fail out of 40. So it means failure in this case is my event of interest. So that's what I'm saying, that usually in binomial distribution, the event of interest, it enjoys the first mention. The event of interest usually enjoy what? The first mention. Now look at this question on the screen. 4 out of 20 rats die from the drug before the experiment is over. So it means death. Look at that word there, die. In other words, it means death is our outcome, is our event of interest. Event of interest may not necessarily be an admirable thing. It will not necessarily be a pleasant thing. Are you getting my point? So don't miss it up, please. So death in this case is described as our success. And recall that P is the symbol to stand for our success. So it means if I'm to write this thing now, I will say our P. Please look at the screen now. I'm going to just illustrate somewhere on the screen. It simply means that our P, which is success, is equal to what? To 4 over 20. Is there anybody that does not understand this up to this level? Please speak now. Is there anybody that does not understand what I've just explained now? Anybody? Nobody. Nobody. Can somebody now tell me the probability of failure? What is the probability of failure?
It should be 6 over 20.
Think about it again. Look at it again.
No,
I guess it should be
it should be 16 over 20.
16 over 20.
20.
16. So I recall that the symbol for failure is what? Is Q, which is what? 16. Recall that the complement of each order. 16 over 20. Good. Is there anybody that does not understand what we have said so far? Don't understand what we have said so far. Speak up now.
Sir,
So
sir, please, for the second one, this 16 over 20 now. Normally, okay, this 16 over 20, was it gotten based on the concept of binomial distribution, in that you can either get to outcome, either true or false, or yes
Yes,
or no,
now.
or
Yes, now. It's a
dead or alive?
complement. Success is a complement of failure. Failure is a complement of success. So if
Okay,
4
so
over
that's
20 is a success, then the failure will be 16 over 20.
okay, but this 4 over 20 were the rats that died,
Yes, now.
and is our event of interest, which is
Yes, which is the success, which is
okay, which is the success. Okay, okay,
yes.
okay. Okay.
Any other question?
So my question is based on the second part of the question, that 10 animals. I've been looking at it. I don't really get how to attempt it.
Which one? Which one?
The second part of the question that says if 10 animals are treated with the same drug, I'll be with the drug.
Oh. Is that Esther? Is that Esther? Is that Esther? Who is speaking? Let me check.
No, sir, it's not Esther.
Okay, Ngozi, Abi.
Yes, sir.
That's Ngozi. Okay. Ngozi, you are getting impatient. I've not gotten to the place you are asking question about. I'm explaining the statement one after the other. Okay? So I
Okay,
want to
sir.
be sure you've got you're clear with the second statement on the question. But you are talking about the third statement. So let's stick to the second statement first. Okay. But Ngozi, do you understand the second statement? Question. Where we got 4/20, 16/20. You understand?
Yes, sir. Got it. You said that P is for the success, and then the success now is the death. Why the other one now is failure? That's the number that didn't die.
That survive. That's the word, survive. Survive. Okay. So now let's go back to the question now. So if the second statement is clear, now let's go to the third statement. Third statement is now where there's a problem to solve. Okay? There's a problem to solve. Okay? Now the question now says, if 10 animals, let me change to a cursor now. So we say if 10 animals are treated with the drug, if 10 animals are treated with the drug, what is the probability that at least 8 will be alive at the end of the experiment? If 10 animals are treated with the drug, what is the probability that at least 8 will be alive at the end of the experiment? Now, you will use the first statement, the second statement, which I've just interpreted here, to get your P and your Q. Okay? You will now substitute this value into your formula. Recall that the formula is this. Look at the formula again. Okay? This is the formula. Okay? You have seen P here, you have seen Q here. So you know what to put at P, you know what to put at Q. Okay? So what you are now left with is what this R should be and this N. This N is the total number they have given to you now. And that is your 10, this 10. This 10 here. If 10 animals were used, 10 is the total possible outcome here for this question. So this 10 becomes your N. Okay? Am I making sense? Are you still with me?
You are making sense, sir, and we are with you.
Okay, good. So I'm going to stop sharing this thing and now go back to a whiteboard so that we can solve the question together. So I go back to my whiteboard. Go back to my whiteboard. I pick a pen. So I have my N is equal to 10. My P is given as what? 1/5. While my Q is given as 4/5. I hope you are on the same page. Good. Good. You said what? Okay, good. So I recall that.
I'm not with you, sir.
Where are you?
Sir,
Where did I lose you?
get 5? Where did you get?
Okay, who can tell us how I got 1/5 and 4/5?
Sir, I think you did that first one as 4/20, and then for the other one as 16/20. If you divide with 4.
Reduce it to the lowest term.
You just reduce it to the lowest.
Okay. I deliberately did that to know who is
You
following.
use the value for the first statement.
Okay, good. I hope that is clear now.
Display, sir.
Oh,
Okay,
sir, it's not.
good. What is not clear? 4/20. What is 4/20? 4/20 is 1/5.
What about the 4/5? How did you get the 4/5?
That's 16/20. That's 16/20. Right? Is it clear now? Is it clear?
Sir, my own confusion now is that why do we now use n now as 10, not 20 in this case?
Because we only needed that 20 to calculate our probability. But the question we are to solve now puts possible outcome to be 10. Look at that question again. The question says,
Yes, sir.
if 10, now it means possible outcome is 10. If we are dealing with 10. But we must use our 20 to calculate our probability. Okay? Before you can now begin to solve. It's just like you got, how do I put it now? You needed to get the tool to do a work. Okay? Before you begin to do the work. Okay? You now say if 20. I'm sure you have done, you must have been, this is in basic mathematics. You must have done variation. You must have been taught variation now in your secondary school. When you do variation, you have direct variation, you have inverse variation, partial variation. The first thing you do is that you must get a formula. Okay? The initial information given to you will be used to get a formula. They will now ask you that if this is one is this, what should be this? Then you now use that formula to calculate for the new one.
Okay, sir.
Okay. Just a minute, please. So I hope we're on the same page. Where's my screen?
It is just blank.
Eh? Is that what?
Your screen is just blank. Those numbers you wrote on it have been wiped off.
How did that happen?
It's just showing us a white screen.
Okay.
Just a whiteboard.
I'll write it again. I'll write it again. Wait. Just a minute. Let me see if I can pull it up. Okay. So I'm sure you are seeing it again now.
Yes, sir.
Okay, good. So now how do we calculate? Recall that the question is asking us, what is the question? How many of you have copied it down? What's the question now?
So like that is the probability of having it alive.
Aha. So what is the now look at the question carefully. The question says, what is the probability that at least 8 will be alive? At least. Please, I'm emphasizing this again and again. This is where it gets tricky. At least 8 will be alive. Now, one thing I'm sure of is that, I'll keep referring you back to your elementary mathematics, okay? Your O-level mathematics. When you say at least 8, what does it mean in inequality? In inequality, what does it mean? At least 8.
It means greater than or equal to 8.
Good. Greater than or equal to at least 8. It means we are talking about probability of X sorry, let me remove this thing that is back to probability of probability of at least 8 will be probability of x. Now recall that that word random variable is x. Probability of x, when you say at least x greater than 8. How many of you understand how I arrive at this? Probability of x greater than 8.
I understand how you arrived at it, sir.
Is there anybody that does not understand? You know, when you say the probability of at least actually means greater than or equal to, okay? But in inequality, we don't factor equal to, okay? We don't bring it into play, equal to, but rather we say greater than, okay? But it actually means the same in statistics. So it means the interest of the question is the probability of S greater than or equal to 8. Do you understand that? Do you understand that?
Yes, sir.
Okay, if you understood that, then the next thing we're going to talk about is that this probability of X greater than 8 is equal to the sum of probability of 8, that is X is equal to 8 plus probability of X is equal to 9 plus probability of X is equal to 10. Why did we stop at 10? Because our n is equal to 10. Is there anybody that does not understand this? Okay, it is assumed you all understand.
Sir,
Yes.
sir, please, I'm sorry, my screen went blank a little, but I just saw what you did now, so I don't really understand how you got the X into this formula.
That X is the random variable, we are finding the probability. Okay? In every probability question, that X stands for what you are looking for. Somebody is yawning. Okay, good. So, X, probability of X greater than 8. That's what the question is saying. Say, what is at least 8? Recall that the total number is what? Is 10. So it's now saying at least 8. So you now put it as probability of X, bracket open and close, probability of X greater than 8, which is equals to probability of 8 itself, probability of 9, probability of 10. When you sum the three probability together, it will give you the probability of X greater than 8. That's what we're saying. Now, if this is clear, now the next thing we are now going to do is that how do you solve for probability of S equal to 8? Because it is the sum of all the probability that will give you the answer you are looking for. How do you solve for probability of 8? Okay. Now you now go back to your formula. You say probability of X is equal to 8 is equal to n factorial. Recall that the formula is what? N factorial. What is our n now? Our n is 10. So instead of saying n factorial, but let me just write it there so that you know how I arrive at it. So let me have n factorial over n minus, instead of putting r here, I will put x, which is our random variable of interest. Okay? Then our p to the power of x q to the power of n minus x. Okay? Now, please take note for every question in statistics. It's just like, it's a principle, it's a philosophy in mathematics. Before solving a question, you must state the formula. If I allot a total mark of 5 to a question, you stating the formula alone may take 2 marks. Don't just jump to calculation. You must state the formula first. Many people have missed a lot of marks as a result of that. Okay. So the next thing you do here is to now substitute. Now our n is equals to what? 10 factorial. Over what? N minus what? Minus 8. Everything factorial. Then you put 8 again, put factorial. Then you now pick your p. What is p? P is 1 over 5. It's good to put it in a bracket so that we don't mix it up. And it is to raise to power of x, which is our 8. Okay? And then you have your q. What is your q now? Your q is 4 over 5.
Over 5.
4 over 5. It's good we put it also in brackets. To the power of what? 10 minus 8.
8.
Good. I hope that is clear. So,
This one is clear to me.
okay. So this one, what you now do here is to solve for this now. Is to solve. You just solve for this. Let's bring it up. Let me put it on another page. Let me add another page. So what I've written there is pick a pen. I said 10 the power 10 factorial 10 minus 8 factorial in a bracket 8 factorial 1 over 5 to the power of x, which is our random variable 8, and then our q, which is 4 over 5 to the power of n, which is 10 minus 8. So this is how to solve for p, probability of x is equals to 8. The same thing you are going to do for probability of s is equal to 9. And you also do for probability of x is equal to what? 10. So let's start from this first one. Now, there's one way you solve mathematics without belaboring yourself in evaluating every value. Now, by the time you look at this, you realize that 10 minus 8 should be 2 factorial, right? Let me put it this way. You have something like this. This will now be 2 factorial, okay? This is 8 factorial, okay? Then you come here. I prefer changing, yes.
Joe.
You said what?
I can't see it. I can't see the second page. You opened another page. I can't see what you're writing. I'm still at the old page.
How many people can see what I'm writing now?
I can see it.
I can see it as well.
I can see it, sir.
Okay, so what's your name? Who is that person that cannot see it? You need to,
Ngozi.
Ngozi need to pray more. Okay. So
Oh yes. Oh yes.
1 over 5 should give you what now? I like expressing in decimal fraction to make life easier for me. That would be 0.2, right? 0.2. So that I can easily punch my calculator and get the answer. 0.3 to the power of 8. Why this one
Yes,
is
sir.
0.8. 4 over 5 is 0.8. Now I say to the power of
2.
I suggest you
I
I suggest you log in
my
again,
God.
Ngozi, so that you can see what we're doing. You can just terminate this end the section at your end and log in. So now let's begin to evaluate this one after the other. Now, if you look at this 10 factorial now, I said that 10 factorial is 10 times 9
Times 8, times 7,
8.
times 6.
But I'm not going to break it down to that level. I'm just going to stop it at this, okay? So this is 2 factorial. This is 8 factorial down, okay? I'll just use this 8 factorial to cross out this 8 factorial. The one up crosses out the one down. And then I can say 2 factorial is equal to 2. 2 here, 1. 2 in 10, it will give you 5. So 5 times 9 should give you 45.
Okay, that's
So it means I've reduced everything here to 45. So I will have 45 times, okay, times 0.2 to the power of 8. Okay? 0.8 to the power of 2. Is there anybody that does not understand to this point? Nobody. Good. So can somebody point the calculator and tell us 0.2 to the power of 8? What should it be? And 0.8 to the power of 2.
0.2 to the power of 8 is 2.56 raised to power 6.
Okay, just a minute. 2 point what?
20 million.
2.56 to the raised to times 10 raised to power 6. Raised to power minus 6, sorry.
Minus 6. Okay. How about 0.8 to the power of 2?
0.64.
0. So this is becoming clearer, right? You can multiply all these together and let's add the answer. Whatever answer you get, what you have just calculated for is the probability of x is equal to 8 at the end of all this calculation. Because that you are not going to calculate for probability of x equal to 9, probability of x equal to what? 10. And you now add everything together, and that will be your answer. Do you understand?
You do, sir.
So, sir, you mean that the answer of this one now is the probability of x to 8?
Now that will now, so the sum of the whole thing will now be, the sum of these three will now be the probability of x greater than 8.
Or equal to 8.
Greater than or equal to, but like I said, we don't talk of equality like that in statistics. So probability of x greater than 8. So that's what will now give you this, and that will be your answer. Any question? Any question? Any question?
So, sir, you mean that whatever answer we get here now, after multiplying 45 times 2.5 times 0.64 raised to power minus 6, that will be the answer for probability of x equal to 8. Then
Yes, you now calculate.
X equal to 9 and x equal to 10. We'll now submit the whole thing to
sum everything together to get
our answer.
Yes, and that will be your answer.
Okay, you said this thing is 2 marks.
Why are you bothered about the marks? It's not the marks you need to hear now. What you are interested in is having an understanding of the context.
Okay.
Leave the marks alone. Somebody is playing with my screen from your end. I've given you license to edit my screen, but you are now playing with the screen.
Who is playing with his screen?
Somebody has reduced the screen completely. I could barely see it myself.
Ah,
Excel.
That boy,
It's
that
not
boy.
Excel now. Stop
looks-
calling Excel, please. Yo.
This person
Please,
look like-
It's Excel.
implicate.
It's Excel.
Okay.
But sir, can you expand the screen back?
I'm trying to.
I'm not even seeing any screen that has been minimized. I thought everybody can edit the size of the screen from his phone.
Person has reduced it. He has zoomed it down completely. Anyway, don't worry. Maybe subsequent classes I will deactivate contributor so that you will not be able to edit myself. All right. So, any question, please?
No, sir.
So, what you are going to do is that you're going to finish the rest of the question for me.
Ah,
So, I've solved it to a point. So, you are now going to solve for probability of x equal to 9 and probability of x is equals to 10. And you sum it all. Okay? And again, I will terminate this slide and I'll look at the second question now. The second question, let me quickly share my screen again. Okay, so look at the second question now. I believe you can all see my screen. So the second question says two parents have the gene for cystic fibrosis. For each of their children, the probability of developing cystic fibrosis is 1/4. If there are 4 children, find the probability that exactly 2. Now, please take note of this, which is the last thing I'm going to see. When you say exactly 2, it means what you are looking for is probability of x equal to 2. I hope that is clear. Probability of equal to 2. Unlike the first question here, I say at least 8. At least 8, you are saying probability of x greater than 8. But when you say exactly 2, okay, in this case, equal to 2. You can also have a question that says, find the probability that at most 8. You understand? So please take note of this. Okay? Now, there's something I want you to, I'm going to edit this question. I'm going to edit this question, okay, to suit what I've taught you. What I've just taught you it requires that I edit this question. So let me just quickly do that so that you don't get confused. Okay. Now look at this point. I'm sure you all can all see my screen. So you see this will be alive. Change it to die. You will change it to die. You see it? I'm writing die on top. So you remove will be alive. Okay? That is the perspective with which I solved that question. So when we come in the next class, I will now explain the import of having it stated as will be alive. Okay? So, but I want you to complete that question for me. Okay? You solve the rest and add them up. Okay? To give you the answer to this first question. Now, why this second question? You are now going to solve it as the second question. Yes. Who is talking? Anybody?
We are going to show working.
You show you're working. What? How would you? What kind of question is that? Yes.
So how are we going to type the workings? Is it not like snap it and send?
Okay.
Or
Now you can do this. You can do the snap and send for this one. I will accept snap and send. Okay.
Your
Do the snap and send Send it to Google Classroom, please. Send it to Google Classroom.
Okay, sir. When are we to submit it? Before
You
next
have
year,
to
right?
submit it before the next class. The next class will be on Friday.
Next year.
Which one is next year? Who is saying next year? Is the person serious at?
NG, what are you saying next year?
What will you be doing at home? We're supposed to be having this class all through December and into New Year and all that. You are not disturbed. You can go home, settle down at home. Whenever the class is on, you take your excuse. You take excuse from eating chicken and say, please just give me 2 hours. I'll be back.
Or soaking Gary?
There is no network at home. Oh.
Are you going
Network at
inside?
home, honestly. We go.
Are you entering
So we
inside
are
your
traveling.
traveling inside your
No, we have some.
Climb 3 to get network, sir.
And there's no network.
Where are
No,
you?
it will be different for us.
In my village, we used to climb 3.
Okay, don't go to village then. Stay in the town
No, sir.
or
My
visit your
parents
uncle.
and this is the only opportunity I have to be at home after like 2 years.
After 2 years. There are people
Yes, sir.
that traveled home after 6 years. So what are you talking about? So
So I'm
we
not.
meet on Friday. What's today's date, please?
13.
13th.
Today is 13th. The next class that is supposed to be Friday is still 15th. So we still have time. So we're still going to use the rest of next week. So maybe after next week, I can now release you to spend like 1 week. And then we'll continue in the new year. All right. Thank you very much for your time. If there are no questions.
Sir, excuse me.
You're
Yes.
I
welcome,
didn't
sir.
actually get what you said.
What did I say?
Sir, does it mean we are solving part B? That part B
We are
question.
going to finish the rest of first question and then solve the second question.
Wow.
The second question is very straightforward. It's not as
Okay, sir. So you said that for the second question, we are only finding probability at exactly 2. So we're going to apply the same formula for just 2.
I said the implication of exactly 2 means you are looking for P, the probability of S equal to 2. Or as against probability of X greater than 8. Okay? And I told you to modify that question. Okay? To reflect what I've explained to you. Okay? If you left that question that way, that solution will be wrong to that question. Okay? But you modify it to suit what I've taught you. So when we come back, we'll now remove that modification and solve it as is there. And then I will now teach you what that implies and the difference that will make. I think we have had enough for this night.
Yes, sir.
Please, did someone screenshot the question?
Sir.
What?
Okay, sir, please. The word you're using now, like modify the question to suit what you've taught us for the second one. Like,
no, there's no modification for second question. I'm talking about first question. That first question, you modify it to suit what I've explained to you. I hope that is clear. Is that clear?
That's based on what we solved.
Yes, based on what we solved.
That is based on what we solved for the first one.
Yes.
Okay, sir.
Yes. Any further question? I'm going to share the, what's it called now? I'm going to share the I want to share the screenshots I just made now. The screenshot I just made about the question so that you can solve it.
Okay.
Can you all see the question on the charts? Check your charts. You see the question. You can copy the question from the chart. Can you all see it?
Yes, sir, we can see it.
Please quickly copy it before I shut down this platform. Or you screenshot, whichever one you want to. So you can see a good number of you did not participate in this class. And I'm worried for them.
So Atapa
So
just
the
made
correction in the chat, the picture you sent to the chat, you said we should correct "we be alive" to "dead," but you did not
Yes.
signify it here.
No, just do it. Just do it now. I've mentioned it,
that.
so you just do it. Hello, Doc. Are you there? Doc. Dr. Korikano, are you there? Okay. Okay, good. So if you have copied it, I think we can end this class. So by now, the previous class that we had, the link would have become active because I scheduled it for 8 p.m. this evening for it to be active. The same thing I'm going to do with this particular class. I'm going to upload it on my YouTube page, and I'll schedule it for 8 p.m. on Friday for it to be active. That's when you are going to see it visible. Doc, are you with us?
Yeah, Dr. Leah, really, I'm here.
Yeah, the student may want to they want to hear from you. So we are done for the night. They want us to call you quits. I don't know.
Welcome, ma.
Thank you. I think it's a very good place to stop. Let them go and revise what you have done.
At least for this night. I'm talking about Friday. They want us to.
Yes.
But I told them we're still going to meet again on Friday.
Thank you very much for the effort. Thanks so much.
All right, Doc. Thank you, ma'am.
You're welcome.
So,
You're welcome.
so we meet again on Friday, exactly 8 p.m. But please, I decide to waive my decision to restrict the platform to some of you that didn't attend to my question. But that Friday, I want to beg you, please, if you have not attempted the question, don't even bother show up. Because if we have to make the sacrifice, then you have to make yourself committed as well. Okay, so thank you very much for your time.
Is it this question or the first one of Monday class?
These questions, the questions I've just given you now, must be turned in on Friday, 2 hours before our starting time. All right, thank you very much. Have a nice night rest.
Thank you, sir.
All
Thank
right,
you,
bye.
sir.
You're welcome.